Good evening to you all. My name is Professor Chris Rogers, University of Birmingham. For my sins, I chair the Innovation and Excellence panel at the ICE, and we have the privilege of effectively organising this lecture. So, welcome to the Institution of Civil Engineers. It's the 2016 Unwin Memorial Lecture. And as you will see, it's Civil Engineers' Responsibilities in a Changing World. Brian Collins is going to be delivering it. Welcome to those people online as well as those in the room. So the people in the room will not realise quite a lot of people are watching you from elsewhere. So I'm now delighted to introduce Brian, who is a friend and a colleague. Brian served as a specialist advisor to the House of Lords Science and Technology Committee's inquiry into scientific infrastructure in 2013 and 2014. Before Brian joined UCL, he served as the Chief Scientific Advisor to two government departments, to the Department of Transport in 2006 to 2011 and Business Innovation and Skills 2009 to 2011. So you'll see that at one point he was advising both departments at once. His responsibility there then was to oversee science, engineering and technological activities. The crucial part of this, though, is ensuring that there was a rigorous science and engineering evidence base that could then be used systematically throughout the department's policy processes. It's this evidence base that is so crucial, and I'm sure Brian's going to talk about it. So, over to Brian. Thank you.
Thank you, Chris. Good evening. Thank you very much for inviting me to give this lecture. A named lecture at an institution such as this is always a privilege to be asked to address. That's interesting. Right. The agenda I want to go through is firstly to talk about infrastructure as an example of where engineering really is changing the world and really matters. It's a subject which most of us take for granted, as I'll explain in a moment, until it breaks, and then we are extremely worried about it and disturbed by it. I'll talk a little bit about risk and a little bit about the legacy that previous generations of engineers have left us and that we're now living with, and what the consequences of those might be. Two very important properties of infrastructure and indeed the world we live in is resilience to extreme events of one sort or another, and how interdependent everything is. Whatever you touch in the way in which we live, it has an impact on the thing other than that which you touched, and I'll give you some examples of that. Some innovative issues, why we need to do more research in infrastructure, and in particular why we need to do engineering research coupled to lots of other sorts of research. And that is the basis for a very large investment which Chris and I have been involved in over the last 2.5 years. Indeed, a lot of the early meetings for the development of this UK Consortium on Research in Infrastructure and Cities, which is what Euchric stands for, were held in this building. And then to talk a bit about what the position is of the next steps. So a little bit about infrastructure. It's what most of us take for granted. And most of what we live in this country is that it was developed in the 19th century. Between the period of about 1840 to 1890, we built most of the railways on the back of the canals which had already existed. We put in water systems, waste systems, our cities grew very fast. We put in the early stages of the London Underground and other underground assets, and we started building long-distance roads and rail. And a lot of that is still exactly the same. If you look at a railway map, plus or minus the beaching cuts in 1960s, you'll find that the railway system is pretty well identical to what it was in 1890. The routes are the same, the track beds have not been renewed very much in that period. After the Second World War, when a lot of it was damaged, of course, we rebuilt a lot of it, and in the 1950s and 70s, we expanded a lot of it under state control because all of those utilities were still state utilities. And that included all the motorways we now have. When I was born, there weren't any motorways. We didn't have nuclear power. We didn't have North Sea oil and gas. All of that has gone in that period across the whole of the country. But at that period, in the late 70s and early 80s, the government of the day decided that it was likely to be much more efficient were we to privatise all those utilities and let the market organise them in such a way that their economic value was delivered more effectively. And indeed, their economic value probably has been delivered much more effectively. Whether their social and environmental value has been delivered more effectively is now the issue that is facing us. Because what we've discovered is the telecommunications, water, energy and rail systems, as an example of those, are now so strongly interdependent and yet separately regulated and separately invested in that the efficiency and effectiveness of them as service providers for us to get around, to heat us, to light us, to take away our waste, and for us to talk to each other is maybe not as good as it could be. In the 90s and the early noughties, we put in place various financial structures to get more private money in so that we didn't have to pay more taxes, which most of you would agree would be a really good thing were it to be efficient. It is pretty efficient in the short term. The jury's out of whether it's efficient in the long term, because of course we've stored up lots of debt, which sometime, we're going to have to repay. And we didn't actually replace very much of that aging infrastructure. Most of what we've got is still over 100 years old, and we've set ourselves on top of that some really challenging targets in relation to energy generation and low carbon. So that's the history of where we've got to where we've got to. And the background for the need of research is that we reckon we're going to have to spend £400 billion in this country. When I say we, that's private as well as public money, in case you thought your taxes were going to go up a lot. $10 trillion globally, because all developed countries are in this state, in particular the United States, which of course is huge compared with us. And in the UK, the research in this space, since privatisation, has dwindled from a quite significant fraction of the turnover of the companies involved to of order 250 million. It wasn't thought a particularly sexy subject to do research on until the last 5 or 10 years, and I'll show you some curves later on which show when it started picking up. But over that period of 3 or 4 decades, we've neglected to do research in these areas, unlike research in medicine, in environment, in innovative electronics. All sorts of other areas have been invested in considerably. But these basic things like energy, waste management, water management has really been neglected as an area for research in either public sector laboratories, which used to exist when they were public sector companies and now no longer exist. They literally do not exist. Or in universities, which has been, because there's no incentive to pick up these areas, universities have not picked them up particularly quickly. And what we've been doing over the last 5 years is to start the process of getting universities into a place where they can major in the delivery of research capability in these areas. At the same time, we started to realise that most people are now living in cities. 70% of the world's population over the next 20 years is going to be living in cities. And it's certainly true in this country. And by cities, I mean urban of a reasonably large scale. But the national infrastructure that services the hinterland of those cities and the cities themselves is not coordinated. It's not very well, it's not complete in coverage, and it's certainly insufficient in scale, as those numbers on the top line show you. And there's been no single point of contact, especially when things break, and you will all know, because you will have all suffered at some stage, either a train breakdown or a water leak or an electricity failure, and you turn to say, so who's responsible for that? And the answer is, well, no single person, no one organisation, because everything is linked to everything else. And that means the commercial organisations, the government, city leadership, local enterprise partnerships, Innovate UK, or any other body has no area, no single point to which they can go. And that means it's very inefficient in terms of learning from those mistakes, as we've witnessed in the recent incidents on flooding, that each one is dealt with in isolation from most of the others. And that loss of learning as a result of incidents, as a result of happenings, even near misses, let alone things that actually go wrong, we're left in a situation where we don't understand anything like well enough what the situation is with regard to the infrastructure assets and networks and functionality that we've got. We find out about it when it fails. And that I could encapsulate in one phrase by saying there's no systems view, even more importantly, no system of systems view of infrastructure as a whole. We're continually doing pieces of it in isolation from other pieces. And yet, it is all very richly interconnected, as I'll show you in a moment. Not just technically and engineeringly interconnected, it's interconnected in lots of complex ways. Now, the background to this need for research was incentivized and accelerated by the government, bless them, saying, why don't we bid for investment in infrastructure to do research? This word infrastructure is going to get used twice here with different meanings. Infrastructure in universities, by which I mean laboratories and equipment in laboratories, to do research in infrastructure. So 14 universities, which I had the privilege of convening, got their act together and put in a bid initially for £250 million. And the government gulped and said, that's a lot of money, until we showed them actually 250 million as a fraction of 400 billion isn't a very large amount of money. And so they compromised and said, why don't you have a rather arcane number of 138 million. I don't know where that actually came from, but that is exactly what we bid for, and we won. They then turned around and said, by the way, we'd like you to match that with funding from elsewhere, which we did. So we now have a budget of £276 million going into capital investment in universities in this country, and I'll give you more detail about that in a moment, to do research. At the same time, there was rising commercial interest in cities and infrastructure, and again I'll show you some curves which show how much that has risen in the last 5 to 10 years. So that's the background. So what do I mean by infrastructure? I should have said this earlier, but most of you I think will have realised that, and you'll recognise from those pictures, yeah, that's infrastructure. I understand what those are. That's a power station, that's the Thames Barrage, that's a very large complex motorway intersection. However, there's one at the top right-hand corner that you may not have thought of as being part of our infrastructure, which is satellite systems. All of you are benefiting, as you sit here, by GPS. Not only did some of you use it to get here because you didn't know where the Institute of Civil Engineers was, your phone works because of it, and your car and other forms of navigation work because of it. But most importantly, actually, it is a geolocation device, but that isn't the most important application. It's the clock. It's the clock of the world. Everything is synchronized against GPS clocks. And if those clocks stopped, everything in this building would stop almost instantaneously, because there's no backup on those clocks. There's no resilience, which is scary, because those devices are out there in space. There's a lot of them, so there is some redundancy. But actually, if one fails, as they discovered recently when they tried to do a software upgrade on one of them, that unless that is properly managed, you end up with the wrong result. And the wrong result at that particular instance was the geolocation accuracy was 200 meters out, which for most of you wouldn't worry you too much. But if you're docking a supertanker by GPS, which they do, you could have put a 200,000 ton ship in the wrong place. Wrong place, wrong way doesn't matter too much. Wrong 200 meters the wrong way the other way matters a lot. So GPS and other satellites, meteorological satellites, communication satellites, we take for granted, and they're out there, but actually we depend on them hugely. The other other picture I'd like to sort of talk briefly about is the one in the bottom right-hand corner, which some of you will recognise as a data centre. What you won't realise is that's the cloud. And when you put stuff on the cloud, which most of you will do, either deliberately or unwittingly, you put it in a data centre somewhere. It won't be easy for you to find out where that data centre is, and if it's your personal information, you ought to be worried, because if that is outside the UK, it is subject to data protection legislation, which is not the UK data protection legislation, and indeed in some countries there isn't any, so it could be exploited in all sorts of ways. So you really do have to be careful in thinking about use of the cloud for personal information. Now, there may be contractual stuff in whoever it is you're feeding that information to, which might protect you. But it would be a little bit careful about where your data center is for the cloud. The other thing I want to talk about is risk. When all this stuff was originally put in by the Victorians had a huge appetite for risk, and they had the ability to take huge risks, because they were doing it for the first time. Now, why could they get away with that? Well, actually, something of the order of 5,000 people owned most of the land in this country. They owned Parliament as well, because Parliament was pretty corrupt. So they bribed their way in, not only to control the political power, they controlled the land. There was almost no taxation. And because labour was free and disposable, completely unethical against modern standards, they could do pretty well what they wanted. So if you look at particularly at the railway infrastructure across the country, you can find some enormous structures that were built in that period by thousands and thousands of people who were labouring to build those things in an era when health and safety wasn't words that you ever uttered. And that is what we've inherited. That legacy is what we've inherited. That ability to take huge risks and have an appetite. And over that century and a half, we've now moved to a situation where we're incredibly risk averse. And you've only got to look at some of the indecisions that has occurred around large infrastructure investments, thinking of nuclear power and airports as two obvious and current examples. We've been not prepared to take risks for decades on investment in large-scale infrastructure in a way that the Victorians would have just laughed at us and said that's silly. So dealing with this legacy is pretty important. Some of you will recognise that this isn't a British piece of legacy, this is an Italian piece of legacy, but we do have aqueducts in some parts of our country which were built hundreds of years ago for carrying water around the country from where it rains and can be stored to where we're going to need it. Jean will be able to tell you a lot more about where the details of those are. But we also have assets which are underground and they explode. And I'll give you a more graphic example in a moment. This is actually an electricity, so this is a water main going off, a high pressure water main going off underneath the road. Road surface won't take the pressure. So suddenly you end up with a catastrophic failure, not only of the water system, but of the road system. I mentioned interdependency. That's a fairly simple example of interdependency. Most of you will have seen this picture before. This is Tewkesbury Abbey. It's been there for 800 years. You'll notice where the flood is and where the abbey is. They knew where to put buildings 800 years ago, and it's called not on floodplains. It's not very far away from the floodplain, but it isn't on the floodplain, because that's been there for that time. And we actually can learn a lot from where old buildings are, where the legacy is, and indeed after the Japanese earthquake they discovered a huge number of shrines that were inland of where the tsunami went, right round the edges of where the tsunami went. And they'd been there for hundreds of years because tsunamis had happened before. So the shrines that survived were the ones that were where the edge of the tsunami came to. And they hadn't realised that. They came and discovered it the hard way. So we have to understand a lot about the history of why buildings are where they are and why things have failed or not failed in the way that they have. But we have these large Victorian infrastructural structures, such as this viaduct, which need to be maintained. The asset value of that is huge because the disruption, as we've recently discovered with bridges that have been swept away, the disruption that occurs when we lose these assets is colossal. So we do need to understand how to deal with legacy in lots of different ways. This is one of the case studies. This is just around the corner from here. This is Kingsway. At the top of Waterloo Bridge, most of you will know it, electricity cable blew up, took out the high pressure gas main, 8-inch gas main, and the duct was full of gas and a light for some hours until they discovered where to put the gas, turn the gas off and put the fires out. And as you can see, it was a Victorian tunnel. It was well maintained. There was nothing wrong with the tunnel, but it was a classic example of interdependence where a failure of electricity cable took out a gas main. And that caused tens of millions of pounds worth of disruption just to rebuild it, let alone what was disrupted in the working practices of all the people in the buildings in Kingsway. The Civil Aviation Authority, the standards body for aviation safety, is in that street, and they couldn't work for some days. So actually there was an impact on aviation safety, which of course they had contingency plans for, but nevertheless there was a possibility of disruption into a part of the transport sector which was nothing to do with where this occurred. This one, and you're going to have to read really quickly because I'm going to leave it up there long enough, it happened in East Barnet. And while you're reading, I'll say what happened so that those of you can follow me. Basically, a burst water main. We have this lovely property in this country of overnight, the temperature going above and below freezing. So below freezing, it fractured the water main. The next day, it unfroze and the water came out. The next night it froze around the gas main, which was in the same trench, and fractured the gas main. So suddenly you've got houses with no water, main supply water, and no gas, and therefore no heating. And the gas company in their wisdom said, we'll go and buy a whole bunch of electric space heaters, 30 kilowatts each, hundreds of them, and give them to the houses. And of course that blew the local electricity substation. Well, it didn't quite. So as an example of protocols and investments and people thinking they're doing the right thing, they very nearly did entirely the wrong thing with regard to the infrastructure. Now, of course, the people at the other end were happy to have heating, happy to have water appear in browsers so that they didn't suffer. But in terms of the damage to the infrastructure, they got very close to what might have gone wrong. Now, this clip off that website I took within hours of that event. I looked a week later and all the company names are gone. You'll see there are company names in there. BBC either did or were asked to redact the detail of which companies were responsible for what in that incident. So beware what you read on the web. It may be only partially what the truth is. And this is the BBC website. So that's two examples of where interdependency in a trench under a street causes major disruption. And just as another aside, I did ask someone at a water company the other day whether they were responsible for the damage that was caused by ice, and they said no, only water. Good. Yeah, he saw it pretty quickly too, that this was actually not a good answer to the question. I also said that we had been doing lots of studies over the last 6 or 7 years on system of systems representations. This comes from my colleague John Beckford, who I work with closely, have been for 8 years now. And this is a system of systems top-level representation of GB Railway, the ideal Great Britain railway system. And I'm not expecting you to read all the words. These slides will become available to you. But if I illustrate them by highlighting that up the top, there's a whole bunch of things to do with policy around railway systems that come out of the Department for Transport, where I used to work, the Office of the Rail and Road Regulator, Transport Scotland, etc., etc., Transport for London. Then there's a whole bunch of stuff to do with the environment, to do with groundwater, heat, precipitation, flooding, drought, what impact that might have on the railway system. Then, well, you need money to get a railway system to work, so there's all the financing, the capital funding, the operational funding, the ticketing, etc. Then there's a bunch of stuff to do with it uses up land, doesn't it? So you've got to have understanding of what the geology is and interaction with the other land uses, etc. And then there's the actual engineering of the railway system. There's the trains, the track, the signalling, and everything that goes with it. Now you'll recognise instantly that all those things have to coexist, but they all have to coexist with this awkward bunch, which are people who get on and off trains. And what I discovered when I worked in the DFT was the outer 5 were being worked out reasonably well, but the people bit was missing. Weren't very interested in the people, how fast people got on and off trains, what their comfort factors were. There was sort of listen to focus groups and listen to passengers, and dare I say Southern Rail to anybody in this room, and they probably hit me for swearing. But so what we've been trying to do is to get people to understand that you have to put the people in the system as well as the policy framework and the politicians and all the other things that are in there. And if you start doing that, you'll recognise this isn't just engineering. This is social science, it's economics, it's environmental sciences as well as engineering. And the system of systems representations that we now have to consider, not just for railway systems, but for the whole of infrastructure, has all of these and more components in it. And of course they all interact, as I showed in my diagram just now, in those case studies I just showed. The electricity system can damage your transport system if it is disrupting. So there's another map like this for energy. There's a different one for electricity and oil and gas. And indeed, John and I have 37 different diagrams which show all of these and their interrelationships. It keeps you awake at night when you realise what a complex world we have built. And if we're going to modernise it, improve it and maintain it, we've really got to face up to that complexity and not keep ducking it and just patching things as they go wrong. So the current innovations in order to try and do that are illustrated here, and I haven't got time to go into the great detail. First one is building information management. This is Terminal 5, and there's I think Chris is going to say something about that later. The Institute of Civil Engineers is producing a major push on BIM, not just for buildings, but for infrastructure as well. Tunnels are now really rather in vogue, as you're well aware. There's lots of tunnels underneath us. This is Crossrail. This is an inspection of Crossrail. This is one way of doing inspection, but a more important way is to fill it with sensors that are sensing the state of the tunnel at all times. This is a fairly old-fashioned form of sensors. Lots of new sensors are coming available based on fibre optics work that is being done in Cambridge and Southampton to continuously determine the state of health of our infrastructure, in particular our concrete infrastructure. And most importantly, in some ways, we're also starting to build the factories for making infrastructural components on the infrastructure site. I had the privilege of visiting a large facility in Sydney in Australia where they were building a large bridge over a river, and the factory for building the beams for the bridge was adjacent to the building site. So the liquid concrete and the reinforced steel and everything else was brought to the site and assembled there, so they actually then moved these huge beams about 200 metres and put them across the bridge, instead of taking it from a factory maybe 100 kilometres away and blocking the motorway all the way while they drove it from A to B. And most of you will have been on a motorway, or at some point you've seen a huge great structure, usually in the middle of the night, being taken along a motorway with loads of flashing lights, and you had to go at whatever speed it is doing, not much more than 20 miles an hour. So advanced manufacturing techniques can be exported into the building sites, and some of you probably work with companies who are already doing that. So this is already in vogue, but it's not as widespread as we will want it to be. So those are just some of the characteristics of innovation. So to come back to why did we want to go do this big research program, and I'll just summarise here to some extent what I've already said. Unregulated growth and interdependency. We're living and working in a very different way from how we did 50 years ago, let alone 150 years ago. So the nature of the infrastructure we need is different now from what we've inherited. One of the challenges is, what are we going to need in 50 years' time? Because it may not be the same as we've got at the moment. Is more roads and more railways the right thing? Is it better broadband? Is it better aviation? Is it different forms of shipping and logistics? We move a lot of goods around in lorries. We keep saying we should move it on trains, but we could put it in pipes. We're good at tunnelling now, so why aren't we putting things in pipes? Because you can actually push a lot of bulk material through pipes rather than put it on roads. Why aren't we doing that? Because we tend to separate the capital cost and the operational cost and the operational effect in accounting terms. And that may not be the right way of accounting for the value of the investment in our infrastructure. I'll come back to business models in a moment. Most of our infrastructure provision has been privatised, so the ability to control it when it's out in the market is more limited than were it to be owned and governed by the government of the day, whether it's a city government or a local government. London is a classic example of where local government has actually got a lot more control, particularly in transport, but not in any other area. I was talking to Isabel Dedring, who was the deputy mayor, and I said, what was the difference between transport and energy? She said, well, transport kept coming to my table because I owned Transport for London. I never saw an energy person in all the time she was there because she had no power over what they did. It was a national issue and an Ofgem issue, not a city issue. And yet energy drives this city. So that's weird. And then, of course, it's internationalised, which makes it even more difficult. So there's no central governance of infrastructure as a system. I had the privilege of working with the Council for Science and Technology, which is the Prime Minister's advisory board for science, engineering and technology in 2008-9, and we published a report in 2009 on modernising infrastructure and briefed the then Deputy Prime Minister Peter Mandelson in number 10. And when we'd gone through all of this, he said, well, who's responsible for infrastructure now? And that was really scary because not only did he not know there wasn't anyone and that it had been privatised, he was the Deputy Prime Minister. Maybe you're not surprised, but at the time I did avoid my jaw dropping, I must admit, just. Extreme events are becoming more frequent, either climatic or unfortunately other forms of extreme events, and we don't have very much investment in resilience to them. It's a precautionary principle. Why would I invest in that when insurance will pay for the damage and pick up all the pieces? So the insurance industry and the investment industries have an act to play with regard to how we invest in resilience in a better way. And there's this elephant in the room called low carbon and low carbon targets, which are legally binding by 2050, and yet we have little understanding of the impact of meeting those targets. In energy, it's not too bad. We're moving quite fast, but we're not moving fast enough on transport. We're not moving fast enough on waste, in a lot of other areas as well. So this was the characteristics that caused us to get together to start saying we need to do a lot more research in this space. And then we understood, of course, that it was over 100 years old, as I've said before. And then we looked at, well, where is the research being done? And this is a word map which shows on the left the sort of work that is being done by economists and social scientists of infrastructure investment. And on the right, there is the research that's being done on networks and on engineering and on innovation. And the hole in the middle is where there are any joint papers across those subjects. And there aren't any. This is an analysis of the last 15 years' worth of academic papers in this space across the world. And basically, the economists and social scientists have not talked to the engineers and innovators for that period of time. And yet, we're trying to achieve a joined-up example of infrastructure research. So this actually motivated us to say, well, the whole of our new program has got to be multipolar, and I'll come back to what I mean by that in a moment. The other thing we looked at was, you may be able to read the ordinate words, percentage of all books scanned by Google that include the term down the right. So all of the ones that are decaying are the old terms for utilities, and the one that is rising is infrastructure. But it's only happened in the 1970s and 80s, and this, of course, is across the world. You'll find in Australia and in the United States, because they're big countries, they use the word infrastructure. They started using the word infrastructure before we did. In this country, it really only started happening in the middle part of the noughties. It's only been the word that people use to talk about this space for about the last 10, 12 years. Which means the literature is fragmented, and the knowledge base is fragmented in sectoral terms and discipline and engineering terms, against those things that are on the right, rather than the integrated system of systems view of infrastructure. And that says something about the backdrop of academic heritage that we've inherited. And this is work that's come out of a project that I currently run, which is a parallel one to the one that Chris is involved in. We could provide you with more background to this were you interested. So I mentioned that we produced this report in 2009. This is actually the headline slide that Sir Mark Walpert, who is now the Government Chief Scientific Advisor, used in his brief to Peter Mandelson. I extracted the slide from the slide pack that he left behind. And this is recommendation number 5. There were a number of recommendations, almost all of which have actually happened, which is good news. And this is the one that was the last one to happen. It's the one we're currently involved in, which is the development of a research and development program collaborative to deal with procurement, to look at research priorities, to deal with interdependencies, scenario planning, and very importantly, since I'm talking in the Institute of Engineers, the role of professional bodies and learned societies, because actually they have a huge amount to play. And the civil engineers here have been playing a huge role in the development of the understanding of infrastructure in the way that I've been describing it. So that recommendation came out in 2009, 7 years ago, and we've just about managed to get the research program off the runway and flying, if I can use that metaphor. Infrastructure research is complex, though. It's a really difficult subject to get your head around, as you may have gathered by now. And it's got a number of characteristics that make it quite difficult. However, this is what we've been using as our guide for research and the capital equipment investment. Multipolar. The word multi, you'll hear applied to loads of words like multiscalar, multidiscipline, multitemporal, and what we're interested in is how all those multis interact with each other. So it's not just multidiscipline. It's sectors in different places talking to each other, listening to each other, that's probably important too, and it's systemic. So for instance, digital technology in concrete structures. Well, where do those two parties meet in many places? Certainly not in university departments. They may not even be in the same faculty. If you look at risk management, it might be in a business school. and it's not in the innovative departments that look at how you take new solutions to market. Robots tend to get done in isolation from where the engineering solutions might be. And let alone citizens. How do you engage with citizens to find out what they think they need, not what they need, what they think they need for their futures? Because that's a piece of social science, which I'm not an expert in, which is arcanely difficult, but nevertheless very necessary in order to understand what society's needs might be. It generates a huge amount of diverse data, from these examples, flexing of rails, to crowdsourced data from travellers, to instrumented bridges. So it's a big data issue, and those of you who are involved in big data will recognise this is a very fashionable subject to get into, but actually as important as big data is getting the right data and getting data with the right qualities, because otherwise you're going to make the decisions which are incorrect and ill-informed. What is also good, because infrastructure is now very visible, is that we have the mechanisms for interacting very quickly into policy, into regulations, codes and standards, which impacts things like safety and growth and resilience. But resilience is this multipolar issue, because there's so many factors which can cause you not to be resilient. It can be as much a societal issue, as we've just discovered in Haiti, as opposed to Florida. If you think that same hurricane went through two places, 800 people died in Haiti, 10 in Florida. How is that? Well, because the resourcefulness of the United States of America is colossally bigger than it is in a very poor country like Haiti. Same tornado. Same hurricane. When we have failure, it has a catastrophic effect on communities, and yet we don't understand in enough detail yet, we're getting much better, of how we recover from those things and how we deal with the important issues as opposed to the urgent issues. And dare I say floods and damaged urban water systems in a week when the flood reports have just come out and there's a huge debate as to whether or not it's sufficient. And of course that takes out communication systems, which is a piece of the nervous system that we've now taken for granted, that you can pick up this device that most of you have got and have been asked to switch off or handed in for recycling, that actually it works. When did the last time you used it as a phone? Actually, probably you don't use it very much as a phone. I don't very much. And if you did, when was the last time you dialed a number? Dial? No, you don't dial, do you? We still have these words which are in our language, which are back to analog systems. When was the last time you keyed a number in which connected to the wrong place? I can remember doing that with an analog system because I'm old enough. But you will press a long number and it will connect you to somewhere in the world within seconds without fail. It may not connect you there, but it won't connect you to the wrong place if you put in the correct number. So we take these communication systems for granted, and that is when, if you lose it, and we lost it in Yorkshire as a result of the flooding last winter, you suddenly find all sorts of other things break down because you don't have good communication systems on which we are now dependent. And yet we spend 50% of our resources across the planet on infrastructure. It's such an important subject. And we can achieve much better value propositions for the way we live, much lower costs if only we did it properly and we did it more systemically. And that is the thesis that is behind our programme. It's also a subject which you have to do at scale. You can't sort of do 10th scale models of some of these things because we don't know how they scale. So you actually have to build things at the scale you're going to put it in the street or in the grid or in the railway system. And we've lost the ability to do some of that. Network Rail, when it wasn't Network Rail, it was British Rail, had a test facility for running trains over many tens of miles. And then someone said, well, we only use that once every 5 years, so it's not economic to keep it, so we'll sell it. Now they do development and testing on the live railway system, which is the one you and I travel on, which actually, if you're any form of engineer, is a crazy thing to think of doing because you might break what is otherwise a national asset. So we have to do research at scale, which is why the investment in all these capital facilities in the universities was so important. And we need to continue learning. You may recall I said some time ago in my lecture that actually we didn't learn from all the mistakes. So we also embedding in what we do the context by which we learn, both academically and organisationally. And that's particularly important because a lot of things are changing quite rapidly. And if you don't keep learning, continuously learn, you keep either ignoring things that you thought you did know or repeating the mistakes of history. So the vision of our program, Euchric, is, as you will have gathered by now, that we don't extract enough value from what we invest in, and it's unsustainable, and the cost of ownership is unaffordable. As we've discovered when we look at the price we're going to pay for Heathrow, the price we're going to pay for Hinkley C, the price we're going to pay for HSN 2 and upwards, then all of those numbers are going upwards and upwards and upwards. And as taxpayers, we don't want to pay more tax for that, do we? And if the markets aren't prepared to invest in it because we don't have the confidence in the outcomes in financial and social terms, then why would they put the money in? So our vision is to create this program that delivers outcome analysis and advice to government and to investors that get us into a much better place. And therefore it's a partnership between industry, broadest sense of the word industry, it implies financial services as well as engineering companies, government and academia. We said we've got this 276 million, that's where we started in academic institutions, but we're going to put a lot more money, if the research councils will provide us with it, and other funders will provide us with it, into multidisciplinary research and teaching programs. There's 3 elements to it: an observatory where we're going to gather real data from real cities in particular about what is going on. We have the laboratories where the facilities and research will be being done at scale on big issues. Chris has a large laboratory that's going to be built to look at underground assets. Most of you who live in urban environments will walk by works on occasions and see pipes and drains and all sorts of things buried in the mud. Well, they're going to be continued to be buried in the mud, and we need to understand much better what we've got and how it works together. And then we're going to do a lot better with simulations and modelling using advanced computing techniques and visualization techniques to understand better the whole impact of engineered solutions on what we're trying to do. And you can see those things are synergistic, and they need coordination, so we have a coordination function that sits in the middle. There are very few programs outside defence that are in any way of this scale that are being coordinated. There are some, of course, in medical research because there are big ticket issues to be concerned with there. But outside those areas, there is nothing that has been attempted at this sort of scale in the last 30 or 40 years. So this is breaking new ground in the way we govern a very large research program. And the clusters of research that exist are in this sort of topic area. You'll recognise, I hope, that you could identify wherever you work in the organisations that you have an identity in one or probably more of the outside ellipses. But putting it all together, this bit in the middle, which is the bit that I'm sort of looking at right now, and I mean literally right now because the proposal for funding that has got to be in by tomorrow, is to get all that lot properly coordinated. And you'll see it's multidisciplinary. For those of you familiar with research councils, it's multiple research councils too. So it doesn't just come from what we call the Engineering and Physical Sciences Research Council, it's economics, it's national environment, and we'd ideally like to get public health in there, because public health, were the infrastructure to break badly, could cause us to have public health problems quite quickly. There are 2 areas in particular: water and waste management. Some of you might recall, no, most of you are far too young to remember when we had strikes of refuse collectors and we had black bags piling up by the thousands in the streets, and that started to get really worrying with regard to public health. So those research clusters, we've already started this process, and to give you again a feeling of what multipolar research means, this is actually a Wordle diagram that came from an event that was held to look to see whether we could use high performance computing to model large scale water systems. And this was all the documents that came out were then put through this lovely machine that determines the frequency of occurrence of the big words, and as you'd expect, waters and simulators. But if you look at some of the other words there, like business and risk and city and management and billion, options, demonstrators, all of those are sort of words you wouldn't expect to find in a research program about water. But if you're talking about the water system and the water system of systems, then it is the sort of thing that you would get to see. And that's why this program is attracting attention from a wide range of communities to invest in. Not necessarily money at the moment, but invest time in helping us construct it in such a way that it adds value. And this coordination function is really important. So the coordination itself is likely to offer some quite significant research challenges, because, as I said just now, we haven't done anything like this at this scale for decades. So intersectoral systems thinking and resilience. We've had conversations with some large construction companies already who say if only we were asked to look at these things by our clients, then we do a much better job in delivering much better solutions. But because clients don't ask for it, it's very difficult for a company to say, you've just asked us the wrong question, so we're not going to bid. You're not going to do that. That's sort of not a good commercial offering. So we're trying to get into a conversation to get the business models between clients and supply side into a better place with regard to intersectoral systems thinking and resilience, and in enhanced value capture and cost reduction by sharing assets in a resilient way. As I indicated in the examples I gave earlier, putting everything in one trench may look very cost effective, but it may not be very resilient unless you take precautions to make sure your fractured water main doesn't take out your gas main. Adapting to future needs. Can we make things more adaptable so that we don't have to dig it up all the time? We can change and repurpose the way in which those systems and assets are used. It's pretty obvious that we have a massive export capability if we do this properly, not just to developing countries, but very importantly to developed countries, but very importantly to developing countries, because it's very important that we understand how they will develop their own infrastructure, because if they don't, they may not choose to live where they currently live. They may want to come and live where we live. And if you look at the population diagrams of the world, you'll find that most of the really rapidly growing countries with populations that are less than 20 years old are in Africa. 45% of Nigerians are under the age of 15. Yes, I see you go, what? In 20 years' time, where do they want to live? And that is a problem. You think we have a migration problem, we haven't seen anything yet. And that cross-fertilisation of ideas between sectors and disciplines is really rather important, because that allows us to accelerate the rate at which we innovate, accelerate the rate at which we renew and replace what we've got. And so we're bidding for funds to carry out all that research. I said I'd say something about business models very quickly. The business model for us is an advisory board that will set a strategy which is internationally informed. We have an observatory which is already starting in Bristol, Newcastle and in Birmingham, in order that cities, which is where a lot of us live, understand better what's going on. I'm not excluding London, but London as the mega city of Europe has some very unique properties. So we're trying not to be dominated by London, because although it's 8 million people, that is still less than 10% of GB population. So London will do what London needs to do, but it's not a very good example for what we might do elsewhere, even though some of the more detailed things could be reproduced elsewhere. We've got this coordinating node. These are the universities, if anyone is interested in who are the players in all of this. You'll see they're pretty evenly distributed across the country, which is important politically, but it's actually practical that we're using the expertise and experience across the country. And we're talking to Innovate UK. Indeed, Chris and I were at a meeting with Innovate UK yesterday to talk about exact, and we're talking to catapults, for those of you who want to know about catapults, next week. We're linking to all the programs that currently exist. We're starting to produce this research program proposition for the next 5 years, and we want to sustain it over decades, because as I said, we neglected it over decades. This is not going to be a quick fix. This is the start of a process which hopefully the younger people in the room will come back to in 5, 10, 15 years time and say, what happened to Euchric? It's going to be still running, and it's still going to be delivering value to the investors and the practitioners and the operators in this country. But we also need to set up an international research collaboration. I get emails at 5 o'clock in the morning from Australia saying, can you come and talk to us about Euchric? They want to call it UKCRIC, which I thought was nice. So the current position is we've had the peer review of the process. We actually had the business case confirmed in March 2015, and it was ratified a year later in the budget in 2016, just to show you what it takes to get a program of this scale through the public sector gateway review processes to get it approved. Even then, we still haven't got the money. But the aim is to get 400 million over the next 5 years with these universities. The next steps are conversations with industry, catapults, professional institutions. I regard this as an opportunity to have this conversation, and hopefully we'll have a conversation if I shut up in a moment, and with government departments and agencies. So we're pushing ourselves out now quite widely to a range of different people who ought to be interested in what we're attempting to achieve. We're putting in proposals for modelling, data, coordination, and sustaining that. We've got big meetings with industry. I had a quick check through the list of the people who are here. We're talking to the CEOs of a lot of the big companies that some of you work for to make sure events are being held before Christmas this year to make those conversations real so that we know what the needs are going to be and where the weaknesses currently are, not only in research but in teaching, in skills and in knowledge. And we've already had workshops which will refine some of the arguments that we want to take forward. So what's the role of the engineer in all of this? Some of you may not know where the word engineer came from. It actually comes from a Latin word meaning ingenuity. And we've applied ingenuity actually to the physical world. That's where most of you will think engineering is about. But actually, if you think about financial engineering, that isn't the real world. Most people discrediting financial engineering as being something that is probably very close to the line of being legal or unethical, and in some cases it has been. But you can be ingenious in lots of different ways than just the traditional engineering sense. And I think there is now a role for people who understand the engineering method to apply that ingenuity in lots of other places to deliver cross-sectoral, multipolar outcomes that are valuable. And therefore bringing those engineering methods on a greater range of issues, I think, is a huge opportunity for engineers who have the mindset to do so. Not everyone will have, and don't get me wrong, I'm not suggesting deep down silo specialists doing engineering of a traditional sort aren't valuable, of course they are. But some people need, I think, to start linking engineering and the engineering methods with other ways of thinking about solving the problems we've got. And that means we can also act as leaders and be conveners of the debate around integration and synthesis. Because if we can do that, because it would appear no one else seems to want to take up that mantle, they all want to stay in their silos. If you haven't read the book, The Silo Effect, I'd commend it to you. You'll be horrified at how siloed a lot of the world is, including to some extent our own engineering world, but we do have the opportunity now to break out of that. It's not to say we don't need specialists, don't get me wrong, we do need experts, but not everybody should be in that mode. We need many more people who can cross these silos and integrate and synthesize the conversations that need to exist between these groups of people. So there's a big role for the engineer there. And importantly, that voice is loud and early in the development of a purpose for achieving something. All too quickly do we climb in on calling something a project or a scheme to make something happen without thinking, so why are we doing this? Because if there are other ways of doing what we need to do, maybe the way that is already enacted in a project is not the correct way of going about doing it. And there's a culture there of moving it from a concept to a project in days. And I witnessed that in government, because politicians want to turn it into something that they can shout about. Well, that's really dangerous. Kept saying, no, don't go there yet. Give us a month to think about it. No, I haven't got a month. And then, of course, they go and talk to the media. Then it's done. You can't undo that conversation once it's happened. And no doubt all of you, probably some of you, are in programs where you think, is this actually the right thing to be doing? It may be paying your wages, but actually it's interesting to know how did that actually come to about? Because the practicality of any proposed option is a very important factor. I had the doubtful privilege of looking after the energy portfolio briefly when it was in one of the departments I was the CSA for, and I'm not going to tell you who it was, I'll let you work it out from the chronology. But this particular Secretary of State said, we're going to develop this amount of electrical energy from the North Sea wind farms by 2020. And you only got to sit down with a very small pad of paper and a pen and say, actually, Secretary of State, you're not going to be able to do that. And he said, oh yes I am, because I've set the target. The engineering feasibility and the economic feasibility was so far off the planet, it just wasn't true, but didn't care. And he went and talked to the press the next day, and then we were stuffed. We had nowhere else to go. Well, actually we did, but 5 years later, thanks to democracy, those objectives have now been removed, and you know, we're now in the right place, thank heavens. So, to close, these are the places where we do the engineering. That's one view of the, and you all recognise that, that's one view of the engineering, and indeed the appetite and current activity is usually measured by the number of tower cranes that exist in a city. you can determine the health of an economy by counting the number of tower cranes. And if you go around London right now, there's a lot, which is sort of good news, really. So you can take that view of London and say, yeah, well, it's all about the buildings. But you can also take that view and say, wow, that's a really complex set of networks, because every pixel in there represents the consumption of all the infrastructural services that I've just provided. Although they're lit up, they are lit up because people are consuming things, mainly through electricity, of course, because that's what lights us. It used to be gas, it would have looked pretty black then. And that shows us something about the density, something about how we are living in our urban environments, and indeed travelling around our urban environments in this parking lot called the M25. We also have heritage to worry about. Some of you may think that's a photograph. It's actually a painting by Canaletto in the early 1700s of Westminster Abbey. And you may have noticed from the headline on my CV that I had the honour of being given an honour by the Queen, Companion of the Bath, which is the third oldest honour in the heraldry of this country. And that is the procession of the Knights of the Bath in 1720, painted by Canaletto. So for me, there's two bits of heritage in here. One's the building, but one is actually the social fabric of, and you may or may not like the honour system, which is part of the fabric of this country. It's part of the fabric of the society we have. All countries have these things, and thank heavens we have a democracy. You can like it or not like it, but we do have it. And you'll all have some piece of heritage that you belong to, which is part of the social and cultural heritage. And some of that actually was ingeniously constructed in order to provide either soft power or influence in the way in which we run our countries. So don't neglect soft power and soft influence, because they are very important parts of the way in which democracies work. It's not all about legislation and regulation and standards. It is about influence, it's about who you know, and it's about process that is in the conversation that we need to have across our country. So that's where I'd like to finish, and I think, Chris, we may have some time for questions. Thank you very much.